Make sure to check out this video first. Okay, let's go over a few simple examples of a hash map. The first will be a basic hash map implementation. The second will be with collisions and chaining, and the third will address complexity and performance. Example 1, a simple hash map implementation without collision handling. Let's set a fixed size for our hash map and create an array with size slots all initialized to none. This is our hash function that uses the length of the key. In this definition, we get the hash for the key, and if the slot is empty, we insert a value. If not, we have a collision. Then we get the hash for the key and return a value at the hashed slot. Here's an example implementation. Keep in mind that the data for David will cause a collision. For example 2, we will use chaining to handle collisions. Each slot in the hash is a list that can handle multiple entries. To start, each slot now holds a list instead of a single value. Same simple hash function as before. Then we get rid of the hash for the key, retrieve the bucket at the end of the hashed slot. If the key already exists, we'll update the value for the existing key. If the key doesn't exist, append the new key value pair. Finally, we get the bucket at the hashed slot. Return the value if we find the key, return none if the key wasn't found. The implementation this time will not have a collision. In the third example, we will include resizing to address the load factors and maintain performance. To start, we're keeping track of the number of key value pairs in the hash map. Initialize the map with empty buckets. The hash function is the same as before. Resize is a private method used to increase the hash map size and redistribute existing key value pairs according to the new size. This is necessary to maintain efficient operations as the hash map grows. We will rehash each key according to the new size. Place it in the new map and replace the old map with the new one. Here the load factor is the ratio of the number of stored entries to the total number of slots. Resizing helps to keep the number of collisions low and lookup times fast. If the load factor exceeds 0.7, resize the map. Get the bucket key at the hashed slot. If the key exists, update the value. If the key doesn't exist, append it. Increase the count of stored items. Then get the bucket at the hashed slot. Return the value if the key is found. If the key isn't found, return none. In the implementation, we will add enough to trigger a resize, and it should reflect the increased size after resizing.